Okay, in the previous tutorial, we started covering WaterGEMS, of course, as a hydraulic modeling tool for designing water distribution network. Today, we are going to proceed with WaterGEMS and we are going to add more concepts that we did not cover in the previous tutorial. So if you're interested, make sure that you watch until the end. And if you're new here, my name is Engineer Lodrick and this is Hydroinformatics Academy, a place where we discuss about technologies related to water supply and irrigation. With that out of the way, let's get started. Okay, so this is our software, which is WaterGEMS Connect Edition. Then from here, if you don't have this kind of window, what you need to do is to select the new. So you just go to File and select New, or you can just click this area here. You can see you have the new options here. Or if you're using Windows, then you can just click Ctrl N. Then this window here will be activated. So before we even do anything, what we need to do is to make sure that we have the settings or the default settings that we want to use for our project. Okay, so with that, the first option is to select Home, then select Options. Okay, so this is the first option. And again, if I select this one, you can see I have this little window here. And we have these two options, Transient Solver and the Steady State or EPS Solver. For now, we are interested with the steady state and the EPS solver. Okay, so I will select this one here, base calculations options, and I will right click it and select properties. Then as soon as I click properties, this is the window that I am having. Now we have several options here that we can set. Okay, so the first one is a friction method. For now and for this tutorial, I don't want to use the Hazen-Williams, I want to use the Das-Westpac. Because the previous tutorial we used the Hazen-Williams, so this is the Das-Westpac turn. Okay, so let me select this Das-Westpac, and again the other calculation, the other settings, of course we can just maintain calculation types, and also time analysis type. Of course, for now I'm going to use a steady state, so I'm going to stick with the steady state. But if you are using a EPS or extended period simulation, then this is the option to change. But for now, I'm going to stick with the steady state. And the other option, of course, the engine compatibility. Of course, we have several options here, but I'm going to stick with the default value, which is WaterGEMS 2.00. Okay, so that is setting number one. Let me close everything, actually those two windows. Then the next option for settings is to select tools. Okay, so apart from home, let me select tools. So this is the other areas that we can change some settings here. Of course, I'll just select this one. You can see this one here. Let me select options, and this window here is going to appear. Now from here, we have several options that we can change, okay? But what we are interested with is the units, okay? So of course you can change these global values. Just make sure that you go through them. And if you want to change anything, you can change it from here. But for me, I'll just go straight to the units. And this is very important, guys, because we want to select the SI unit. Of course, if you want to use the empirical units or the US customary units, you can set them from here. But for me, I am interested with the SI units. I'm going to select this one, and of course I'll make sure that I maintain the SI units. So these are the other units that you can change. Okay, so these are the units that you can change. For me, I don't think if there is anything that I can change, but for now, let me click OK to close my window here. That is part one done. Of course, we have the units that we want to use. The next step is to make sure that we draw our actual network. In the previous tutorial or the first tutorial, we used this option here. Okay, so we entered each element one by one, okay, reservoir by itself. But for now, we are going to use the other option, which is this one here. So if I click this, you can see we have this option, and if as soon as I clicked it, we have this junction icon there. You can see that black dot, so that is the junction, right? But I want to draw the reservoir, but for now, as you can see, the junction option is activated, and this is something that I don't want. So I'll just right click my mouse, and from here I'll just select the reservoir, okay, reservoir, because this is what I want to start with. Okay, so as you can see now, the reservoir option is activated. Now from here, I'll just click somewhere here. You can see now the reservoir is activated already, and we have our reservoir here with a label R-1. But if you can see my cursor, the reservoir option is still active. But for now, I don't want to use the reservoir anymore. What I want to use is the junction, right? Now, if I right click this, okay, if I right click, you can see we have the other options again. So I want to select the junction, and this is my junction. Let me introduce the junction here. So this is junction J1, and again this is the pipe P1. Okay, so as soon as I click this J1, this P1 link P1 is activated. Of course, link is the pipe. Okay, so for now I need to add the other junctions here. Okay, and this one. So if I want to close here, I can just click on top of J1, junction 1 here, just click on top of it, then we are done. But to close everything here, you can just click escape, or you can just right click and click done, or you can just click escape. It is the same option. But for now, this is the first part of our network. I need to draw the other part. So if you clicked escape, then this window is the layout option is deactivated. So I need to click it again, and to click on top of J3 and to introduce the other part of the network. Let me select this J5, and also I need to click somewhere here and also somewhere around here and here, that is J8. And to close my network here, I can just click on top of J5. Okay, now we are done. So from here you can just click right click and done, or you can just click escape to close everything. But for now, as soon as I click done, you can see the layout option is still active. I can just go and click escape. Okay, so now my network is ready. But the next step is to make sure that we edit the properties of each junctions and links. So to do that, we have two options. We can just click here one by one and enter the value. And the other option, and this is what I wanted to cover in this tutorial, is by using the Flextable. So in short, Flextables, as far as WaterGEMS is concerned, are dynamic tables of input values and calculated results. Okay, input values and calculated results. Okay, so we don't need to go and enter one by one properties. So you just click at this junction 1, junction 2, junction 3 and enter the values, just like what we did in the previous tutorial. By using a Flextable, our life becomes even much easier. Okay, let me show you how to use the Flextable. It's actually simple. Just go to home and go straight to this area here. Just click this area. You can see you can even use Ctrl+7 to activate it, or you can just click on top of it. But for me, I'm going to click somewhere here down. This is the options that we are having. But the first property that I want to edit is the junction elevation data. And to do that, I'll just go straight and select junctions here. So this junction here, I'll just select. Then this is the table that we are having for now. Remember, I said that a Flextable are the dynamic tables of input values and the calculated values. So you can see here, the white colored values are the input values, and the yellow colored values, these are the results. Okay, so because we want to insert our values, then we need to use the elevation, or we need to use the white colored tables or columns. Okay, so from here I want to enter the elevation value for each junction. So instead of just clicking one by one, we can utilize this Flextable option in WaterGEMS. So from here, what I can do, I need to insert the value for J1. So instead of going and double click it, we can just use this Flextable and enter its value. So J1, the value here is 90. So for J1, and J2, this is J2. The value here, so for J2, the elevation value is 85. And also for J3, the elevation value, is 80. And for J4, the elevation value is 88. And again, for J5, which is this one, the elevation value is 70. And for J6, the elevation value is 66. And also for J7, the elevation value is 65. And lastly, the elevation value for J8 is 68. So this is J8 here. Okay, so if you're done, let me close this. If I double click just any of the junction, you can see the elevation value is here. So instead of just clicking one by one, you can use the Flextable, and that is the beauty of WaterGEMS. Now the other option is to edit the value for our pipes or the links. Okay, but before that we need to insert the value for a reservoir. But because we have just one reservoir, I can just double click it and enter the value manually. But if you had a lot of reservoirs here, you could go and select the reservoir here. Okay, so if you click this, you can see we have just one, but if you have more than one reservoirs, all of the reservoirs will be here. But for now, I want to double click this one and enter the elevation value manually. So the elevation value for our reservoir or our source is 100. Okay, now we are done. So the next step is to change the value for our pipe or for the links. Okay, because we have more than one, we have a lot of them. Okay, we cannot just go and double click one by one and enter the value just like what we did on this reservoir here, but rather we are going to utilize the Flextable. So if I click this, if I click anywhere here, you can see we have this option here. And for now, what we are dealing with is the pipe table. So if I double click this pipe table here, you can see this is the same table that we are having. Again, keep it in your mind. The yellow colored values are the calculated values, and we are not going to touch anything on these yellow values or yellow cells. But to edit our values, we are going to use only the white colored columns or cells. Okay, so for links, what I need to do is to insert the link length. Okay, step by step, link length. We have done with elevation data. Now we are dealing with the link length. From here, what I can do is to scroll this one all the way to the end. You can see here we have two columns here. So the first one is the has user defined length, and the other one is the length. For now, you can see the length option is not active because it's yellow colored. But if you want to activate this, we need to activate this has user defined length. Okay, so make sure that you put the tick. You can see now we are able to edit these values. So as soon as I tick, we have this, and also if I tick this, we have the option to edit. I'll just take both of them. This is what we're having, right? So the next thing that I need to do is to insert my values. Okay, so to insert my values, let me move this one down around this region. Okay, let me shift this. So this is what we are having. Let me take it back to around this area. You can see now we want to edit the value of R1 to J1, which is this one, which is P1. I don't know where is it. Can I have P1? Let me see if, okay, so which is P1. I need to insert its value as 200, And again, this one here is 200, and again this one is 200. But you can see we have the same values here, but why are we clicking one by one instead of finding a way to edit both of them at once? So if you want to edit the value, both of the values at once instead of just entering one by one, you can just click here. You can just click on this table around this area and right click. You can see we have this global edits. So if I click this one, you can see this is the sub menu that we are having, and it says the values. Okay, so the option is set. Okay, so the option is set. That is very important. We need to set the value for each of our cells here to 200. So as soon as I click OK, you can see now this is what we have. So if you have a lot of links, instead of just going and edit one by one, you can just click here and activate the global edits. So if I want to turn my values, let's say to 250, this is what we are having, 250. Of course, you can just go and edit one by one, but for now, I just want to go with 250. Okay. And the next thing that we can change here, so apart from length, what I can change as far as pipes or links are going is the Williams, but we are not using the Williams. We are using the Das Westpac. Okay, Das Westpac. Okay, so for now we are having the Williams, but we want to have the Das Westpac because, as I said earlier, what we are using is the Das Westpac, but for now we are having the Williams. To go around that, what we can do is to select the Flextable and select the pipe, and then this is very important, guys. This is very important. Just go here, select this one here. You can see we are having this edit option here. Okay, so if I select this, you can see we have this sub menu again, and if I scroll down, you can see we have the Das Westpac. Okay, so we have these two values of Das Westpac. So I want to select this one here, which is Das Westpac E, and from here, if I want to display its value on our table, what I can do is to select this add here. Of course, you have two options. You can even select add or remove, but because we want to add this value to our table, then what I can do is to select add. Okay, so I'm going to click this add. You can see now we have its values here. But we want to remove the Williams C because we don't want to use it because we are not using the Williams. Again, to remove any column on this on our flex table is to just select the parameter or the property you want to remove. For my case is Williams. Just select it and click remove. So if I select this and click remove, this is what we have. Okay, so from here I'll just click OK. You can see what we are having is the Das Westpac value here. But I want to move this Das Westpac to this area, of course, in this areas somewhere here. Okay, so if I move this, you can see now I am having that option. So I want to move this Das Westpac to around this region. So you just click and hold, then move to whatever position that you want to move your value. Okay, so for me, that is okay. That is fine. Okay, so now it is fine. Okay, so what I can do next is to close this. Oh, not yet closing. So I need to change the pipe material. Okay, so now we have done with specifying the length and also the Das Westpac parameter. What I can do next is to specify the pipe materials. Okay, pipe materials. Okay, so from here, what I can do is to select one by one. Of course, you can click here global edit, but I'm not interested with that for now. I want to change the pipe material for one by one. So from here, you can see this is our pipe number 1 or link number 1. If I cancel and select, and I click these 3 dots, you can see we are having these several materials here. So the pipe number 1 from the reservoir to EA1 is a PVC pipe. As you can see, if as soon as I click PVC, we are having these PVC properties. Okay, so from label all the way to Poisson's ratio. So from here I can just click select. Okay, as soon as I click select, you can see here that even the dust waste bag coefficient is changed. Okay, now from here I can just go and change the other material, and so this one select concrete. Okay, and again this one I'll just select the other pipe material. Again, let me maintain with PVC. Of course, you can just go, I'll just leave it as a DI or ductile iron. And again, this one I want to change its pipe material. From here, what I can select again is steel. And also this one I want to change it to galvanized iron. And also this one here, PVC, I want to change it to PVC from, and again the other one I just maintain the way it is, and the last one I want to change it to let's say PVC. Yeah, PVC, and select OK. So now we have managed to change our length value. Also we have managed to learn how to edit our flex table, and also to add the dust waste bag coefficient. And lastly, we managed to change the pipe materials. Of course, without going and select one by one. Okay, we have done all of that by using this flex table. Okay, now from here, before I click close, before I close this window, I need to change the pipe diameter. Okay, so for now you can see the default value is 152. Okay, I want to change this value. Okay, so from here, but before I change this one, so let me change all of them to, let's say, 90 mm dia pipes. Remember, we are using the hydraulic diameter, or we are using the internal diameter, or the inside diameter of the pipe, not the outside. Okay, I want to change these values, so I can just click here on top of this whole diameter and select global edit. I want to set all of my pipe to 90 for now, 90. Then I'll come and change them later on. So instead of 152, I want to change all of them to 90. Okay, so as soon as I click 90, everything now is changed. Okay, so now that we have the length, pipe length, and also we are having the dust waste bag coefficient, and also we are having the pipe materials, and lastly we are having the pipe diameter. Of course, we will change them later on. I think now let me close this flex table for pipes, right? Let me close it. And for now, if I click one by one, you can see now the values has changed. Of course, the pipe material now is concrete instead of ductile iron. And also the other parameter that we changed, of course, the length now is changed. Okay, and this is the same for all pipes or links. Now before we run our model, we need to insert, or we need to assign the demand for each required node. And to do that, instead of just clicking one node after the other, what we can do is, of course, by using Flextable. No, not Flextable, is by using the demand control center. So one thing that you need to keep it in mind is that the flex table is only for changing the physical properties for pipes and junctions, and of course other options, right? But for demands, we are going to use the demand center, and this is nothing but this one here. So if I go to home, make sure that you are in home. If I click this, you can see we have two options: the unit demand control center and the demand control center. For now, and for this tutorial, we are going to stick with the demand control center. Let me select this, and of course it will tell you just select yes. And this is the window that we are having. As you can see now, this window here is blank. There is nothing here we can work on. But what we need to do is very simple. Just go around this. You can see we are having new. Okay, if you click this, you can see add demand or initialize demand for all elements. For now, because we want to assign demand to all of our nodes, I'll just select this and select the initialize demand for all the elements. And of course, the other option is by selecting one node after the other, but I think this one is a very long route and we don't want to use that. I'll just close and I'll just select the initialize the demand for all elements. Okay, so this is what we are having. Again, keep it in your mind. The yellow colored values are the values that you cannot edit, but the white colored values are the values that we can edit. Okay, we can edit. For now, you can see we have the base demand, of course, which is in liters per second. And if you want to change, let's say the units, if you don't want to use liters per second, you can just right click on top of the base demand and change the units. But for now, I'll just maintain liters per second. So from here, I want to assign the base demand, and the base demand here is flat, which is 1.5 liters per second on each node. So instead of clicking one by one, what I can do is to right click on top of the demand and select global edit. Okay, global edit. I can see now our global edit is active. I need to set the demand, the base demand as 1.5 liters per second. 1.5 liters per second. So from here, just click OK. You can see now, as soon as I click OK, now each and every node now is assigned with 1.5 liters per second as a base demand. Of course, feel free to go and edit the values if you want. Okay. And again, the other option here is the pattern. Okay, the pattern or the demand pattern. But for now, because we are dealing with steady state and not extended period simulation, there is nothing we can change on the demand pattern. And the next thing that we need to do is to close this one, because there is nothing here we can change. But later on we'll come and talk with the patterns possibly later on. But for now, let me close this one. Let me close this. Okay, so this is what we have. So far we have used the Flextable to change the junction properties, link properties, reservoir properties, and also we used the demand center to assign the demand for each of our nodes. Lastly, we need to run our model and see if there is anything that we can modify. But for now, before I click run, make sure you just go and click validate. Okay, just home, then select validate. Okay, this is very important because it checks. So before it run your model, it checks if there is anything that is missing or if you have any error. Then it will just notify you before you even run your model. So for now, I'll just click validate to validate my model. You can see I don't have any problems. Of course, no problems were found. Let me click OK. Now the next step is to actually run our model or to compute our model. So from here, I'll just click here, compute. This is what we are having. Okay, so it says that the flow supplied, of course, from the reservoir is 12 liters per second. Now this 12 liters per second is summation of each and every demand that we assigned in our junctions. And of course, the flow demanded is the same value, but the flow stored is 0 because we don't have any storage tank here. Okay, so the next thing is to optimize our model. Okay, remember, we insert we edit our network parameters by using Flextable, and we assign our demands on each nodes by using the demand control center. And lastly, we validate our model, and then we click compute to run our model. Okay, so the next part is to optimize our model. And by the way, if you are getting anything out of this tutorial, don't forget to hit that like button. Of course, you can help; it will help me a lot. And also, don't forget to share this video with your friends. Now let's go. Let's move to the model optimization. Now, the first thing that we need to do to optimize our model is first we need to see the values, because as of now we only have these arrows, right? We're only having these arrows, but we don't know what are the velocities, what are the flow, or whatever. And to do that, we want to activate the annotation for links or for the pipes. So I'll just go back here, and as you can see on the left here, we have the pipe. Okay, for now the active label, the label is active, so we need to introduce another annotation, which is nothing but the flow. Okay, nothing but the flow. Let me select annotation, and from this window here, what we need to do is to select the results. Okay, results, and select the flow. Okay, flow, and if I click apply, you can see this is what we're having, but it's not looks good. And what I can do is to change the Y offset. So on the Y direction, I need to move it to +2. So on the Y direction, +2, which is upward, +2, and then click apply. You can see now the flow values are not visible because we have this label which is active. So from here, I'll just click apply and OK. And also I need to turn off this label annotation so as this flow value is visible. Okay, so flow value is visible. And what I can do next, as you can see now, we are having negative values. So to solve this negative flow values, just click, then reverse, click and reverse. Okay, and also these two values, just click them and reverse. And also this one here, click and reverse. Now we are having now the flow, so now we are able to see the flow values. And the next thing that we need to do is to introduce the velocity. Then velocity, select our results. Then from our results, I need to select the velocity. Just go down here, you can see we have velocity. Now from here, just click OK. You can see now we are having this value, but I want to push this the V value to -2 in Y direction. So now it is visible. So this is the value. And before I even move further, I want to start to optimize my model by taking into consideration the velocity. Remember, the acceptable range for velocity varies from country to country, but for the most cases is from 0.5 all the way to 1.5 or 2 meters per second. Okay, now from here what we are having is 0.6, 0.8, and again 1.89. Okay, so if I click, so this is what we are having. The next value that I can change and that I can edit, let me add the other value, which is the unit head loss. Again, this is the other parameter that we can use to optimize our model, which is the unit head loss. And for as far as our WaterGEMS concerned, we need to deal with the head loss gradient. Okay, head loss gradient. And if I click apply, then this is the value that we are having. Of course, for now, it is in meters per meter, and this is not what we want, but I'll show you how to edit later on. For now, because we are having it, let me just click apply and click OK, but let me turn it off first. I want to optimize my model by taking into consideration velocity first, then I'll shift to unit head loss. And from here you can see the value that we are having here is quite big, which is 0.89, and also the values that we are having here, again we also need to change them. So let me first remove the flow. So now we have only velocity. Okay, so if this is the value of velocity, I can see that it's quite big, and it's quite big because we are having a lot of head losses. And the only way to reduce the head losses is by increasing the pipe diameter. So if we increase the pipe diameter, meaning that we are going to reduce the head losses within the pipe, and eventually we are going to increase the velocity of water within that particular pipe. Now from here, I can just double click this, you can see, and this is what we are having. So if I increase the diameter to, let's say, 110, remember we are supposed to use the internal diameter or inside diameter of the pipe, not the outside. Let me click close and let me run my model again. You can see now we are having 0.2 and no longer 0.89. Let me increase a little bit and see if what I have, 160 pipe, and see what I have. You can see now this is what we are having, 0.6. Let me maintain this one, then if there is anything that I can change, we're going to change it later on. Now the other area is of course this one here. You can see here we have very little values for velocities, but let me not touch these ones for now, and then let me close, or let me deactivate the velocity annotation and activate the Headloss Gradient value. Okay, as of now you can see it is not as visible as we want. What I can do is to shift this value into positive value. So from here, let me click right click and click edit. This is what we are having, right? Not this. Okay, so this is what we are having. Let me select here, let me click here, then select. Now before we go here, let me select here. So let me put here positive 2. So I want to shift these values here, which for now, they are not visible. I want to shift them to positive 2 value in y direction, which is upward and downward vertically. So let me select this, apply. You can see now the unit, the Headloss Gradient is quite visible for now. But the other issue that we are having here is that we are having the Headloss Gradient in meters per meter, and what I want is to display my values in meters per kilometers. And to go around this, the only thing that we can do is actually very simple. We can use the Flextable, or we can just click one by one, or we can just click just any link, then we can change everything. But let me go back to the Flextable again. Then let me select pipe. You can see now, actually it is not here, Headloss, okay, so this is the Headloss Gradient. What I can do is to right click and select the unit and format. Okay, so this is the first option, and the other option, as I said, is to click any of the link and select properties. Then from here, you can change your values to the value that you want, of course, which is the this one here. But for now, I want to use the Flextable. Of course, feel free to use the other option. So for Flextables, let me select this one, pipe, and the Headloss Gradient. Let me right click this and select units and formats and formatting. So for units, I don't want to display my Headloss Gradient or the Headloss Gradient values into meters per meter. I want to use the meters per kilometers. Okay, and the display precision to 3. Let me maintain 3 for now. Let me click OK. You can see now this is what we are having. Again, for Headloss Gradient or unit head losses, the only thing that we need to make sure that our values are always maintained is within acceptable range. And again, these values here varies from country to country. Somewhere from 5 meters per kilometers all the way to 10 meters per kilometers is possibly acceptable in many countries. Okay, for me, I'm going to make sure that my values are always maintained around 5 meters per kilometers all the way to 10 meters per kilometer, around there. Now from here, I can see the only place where we are having some issues is actually around this area here. Now before I even move further, let me change this one first. And so what does this mean is that we are having a lot of head loss in this area, and this is the reason why we are even having this velocity value, which is 0.9, which is not bad, but this value here is quite not acceptable. So what I can do is to double click this, and of course let me find the diameter. Of course, because we are having a lot of head losses, the only way to reduce head losses is by increase the pipe diameter. Of course, that is one among the options that we can use. So let me find the pipe diameter, which is in physical pipe diameter. Let me increase it to 110 and see what we are having. If this value is still not reduced, you can see now we are having 8. Okay, so from 23 all the way to 8. And what does that mean? Because the head losses are now reduced. So if I check the flow or the velocity or water speed, you can see now we're having 0.6, right? At least for now we're having a good result here. So the next option is to deal with this area. Of course, I want to reduce the precision because I can see these numbers quite a lot. So to do that, what I can do is to go back to my Flextable, or for now, let me double click one of them, and I want to go to Headloss Gradient. The idea is to reduce the precision and all the way to 2. Let's say 2. We want to use 2. Yeah, we want to use 2. You can see now we are having 2, and you can see now here we are having very, very low values for this one, because it is even below 5 meters per kilometers. So what does this mean? It's quite simple. What does it mean is that the pipe that we are using is quite big compared to the flow, or to the flow of water that is passing through it. And the only way to increase these values is to increase the head losses, which in other way to reduce the pipe diameter, so as we can allow accumulation of more head losses within that particular pipe. So from here I can just click this, and what I need to do is to reduce the pipe diameter. Okay, pipe dia. Let me go back here and find the pipe diameter. So for now we have 90. Let me take it back to, let's say, 63, which is 2-inch pipe. Remember, the inside diameter is what is required. If I run, you can see now we are having around 4, which is not that bad. It's bad, but not that bad. Let me take it down to 50. At least for now, that is the value that we're having. And again, this one to 50. And also this one, the same value, which is 50. And lastly, around this region, let me take it to maybe 50 and see what we are having. Oh, I think for now we are having a lot. We introduced other problems. So let me increase this pipe diameter again, 63, and again this one 63, and let's run. Okay, you can see for now this is the situation that we are having. It's not that bad. Okay, and again let me select velocity again. You can see for velocity, as soon as I activated this velocity, you can see what we are having is these values. Of course, we are having some few problems here, but they are not that bad. Okay, so this is the velocity value. And again, the next parameter, so we have velocity unit head loss, and the last parameter that we need to take it into account is the pressure. Okay, residue pressure, whatever. So for pressure, we will not be able to view the pressure on the pipes. Okay, so the pressure, the only way we can view the pressure is by using the junctions. Okay, so from the junction, I'll need to select a new annotation and I need to select the results. And lastly, I need to select pressure. Okay, and as soon as I click apply, you can see this is what we are having. Okay, so the pressure results are in kilopascal, and this is not what we want. Of course, for now, let me shift upward 2, and again in X direction, I don't think if, of course I need to turn off the labels, and that is done. So the label now is off. I need to change its units. Okay, so to edit the pressure values, what I can do is by using, okay, so let me double click one of the junction and find the pressure in this results. Let me find the results pressure. You can see this is what we are having, of course, which is in kilopascal, which is a residual pressure. So let me select this and select unit formatting. Now from here, what I can do is to change my values to meters of water column, which is this one here, meters of water column. Of course, you can use even bar if you want, but for me, I want to use meters of water columns. And again, the precision here, I'll just make sure that I want to at least 2. You can change it any values that you want. For now, I can just maintain the way it is. You can see now, this is what we are having. Okay, so you can see around these areas here, the pressure, we don't have a lot of problems when it comes to pressure, because it is advised that for most reticulation systems or water distribution systems, at least you need to have around 10 meters of water columns all the way to 30, and sometimes even 6 meters of water columns, depends on the country that you are living. But yeah, just make sure that you consult the design manual for your country, then you can see all the required values. But because for now the pressure values are within acceptable values, which by any case is not above 3 bars or not above 30 meters of water columns, so we are going to maintain our model the way it is. Okay, so there is nothing that we can change around this region, okay, as far as pressure is concerned. And the other value, let me go back to pipes and activate Headloss. Is there any other optimization that we can do? Of course, feel free to proceed or feel free to change anything that if you want, but for me, I think because of time, I'll just leave it the way it is. So the next thing is color coding. So apart from annotation, the other option that we can use is color coding. Okay, so we need to classify or to categorize our values, let's say velocity values or pressure values, by using color. So this color present the certain values, or this color the other values. So let me introduce to you the color coding. Okay, so this is the window that we are having. What I need to do is to start dealing with velocity, right? So the field name here, let me select the velocity. Okay, so just make sure that you just go here to pipes and select the color coding. Then from here, this is what we are having. So from here, I need to select the results and select velocity. Okay, you can see this area here is activated, right? Okay, so from here, what I can do, of course, we have the option of using the range, but what I want to use is this area here. Now, it says that velocity or the value less than or equal to, let's say 0.4, we need to assign such a value with red color. Of course, I'll explain to you what does it mean in a second. Let me assign it to a red color, and the values less than or equal to 1.5. Let me assign it to purple color, and the values less than or equal to, let's say 1,000, okay, or 100. Let me assign it back to red color. Okay, so what does this mean? Okay, and this is very important, guys. Make sure that you concentrate here. What does this mean? So what I want is that any value that is less than or equal to 0.4, then I need to assign that velocity value with red color. And the red color, for my case, I want to assign to the values that I need to edit. Okay, I need to at least to provide further optimization, right? So any value that is less than or equal to 0.4, meaning that is the value that is not acceptable as far as velocity goes. and any values that is less than or equal to 1.5 but not below 0.4. This is very important, guys. Any value, any velocity value that is less than or equal to 1.5 but not less than 0.4 should be assigned with a purple color. So this is the value that is somehow acceptable, right? And any values that is greater than 1.5. Okay, so this is what it means. So any value that is greater than 1.5, of course, any value that is 2, 3, 4, 5, then we need to assign it again with red color. So red color is any value with red color is the value that we need to optimize further. I'll just select apply. Okay, so if I select this velocity, you can see these are the values that are less than or equal to 1.5, but they are greater than 0.4, and this is the reason why we are having here the purple color. If I go back here, I need to edit. You can see. Okay, let me move this one here. So you can see, let's say as 0.72. So 0.72 is less than or equal to 1.5, but it is greater than 0.4. Okay, but we are having some red colors here. So the red colors here present the values that are less than 0.4. Okay, so by any chance, these are the values that we need to optimize even further. Okay, so let me select apply and okay. Let me select if there is anything that I can change even further. Let me select 32, which is 1-inch pipe, and again here 32, and let me see what we are having. Okay, so at least for now this is what we are having. Okay, let me select the unit head losses, but you can see even though the velocity is okay, but the unit head losses are quite big, so there is no way I'm going to change. So there is no way I'm going to maintain this 32. I'll just take it back to 50, and again this one, because yes, we have the velocities that are acceptable, but the unit head losses are way big, so I'll just maintain it to 50. Okay, so that is what we have, and of course you can do the same value. So let me do it with let's say pressure. Of course this is pressure. Let me select junction again and select annotation, then color coding, and again I'm going to do the same exercise with the pressure. Remember, we don't want our system to have pressure less than 6 meters of water columns. Of course, depends on what you have in your country. For my country, below 6 meters of water column or 0.6 bar, that is something that is not acceptable. Now, what I can do is to say that value equal to. So before that, I need to activate the field name. Let me select results, then select the pressure. Okay, so value less than or equal to, okay, pressure, which is meters of water column. Values less than or equal to 5.99. We are going to assign it with the red color. And again, values which are greater than 6, values which are less than 30, which is 30 meters of water column, or 3 bars, we are going to assign them with purple. And again, values which are greater than this value, we are greater than these values, then we are going to assign them with the red color. Okay, so how can we do that? So value greater than this value here. Let me introduce the other any values. Let's say 150. Then we are going to assign it with a red color. One more time. Red color are the values that we need to provide further optimization. And as you can see here, any value that is less than or equal to 5.99, we need to assign that value with the red color. And any value that is less than or equal to 30, we need to assign it with purple. Again, remember, any value that is less or equal to 30, but again it is greater than 5.99. Okay, so from 5.99 so from 6 all the way to 30, that is the value that is acceptable. And lastly, we have this option here. So I'll just click OK. You can see even by yourself here, at least we don't have any value that is less than 6, than 5.55. Otherwise, we would have red colors here. But for now, at least our model looks perfect. Of course, feel free to go and provide it to optimize further your model. But for now, this is what we are having. So the last part is to produce the report for our model. Again, this is very, very important, guys. Now from here, what I can do is to select, I need to select the report here, the report option. The report option. Now from here, the first report that I need to produce is pipe inventory. Okay, so this is the beauty of our WaterGEMS. Everything that you need as an engineer is provided right in front of you. So for pressure pipes inventory, I'll just select this. You can see this is what we are having. So this is the diameter and this is the length. Okay, so the diameter, and so this is the diameter, but the length here is 0. So for 90 we have this length. So what you can do, or what we can do, is to select this, and then to produce this beautiful inventory. Of course, if you want to provide this to the quantity survey people, then you can just give them, at least to simplify their work. Okay, because this one here you can see each pipe and its length, and this is very useful. And the other option is to go to report, and this again select the Flextable and select the pipes. Okay, so the idea is to take all of these values here and make sure that we are inserting them we copy them to the Excel. Okay, so for further process. Okay, so from here, what I can do is to click here, just make sure that you highlight everything, and then from here just select this, copy, and then copy with headers. Then from here, what I can do, of course you can use even your Excel, it is okay. So from here, what I can do is to paste, then okay, so this is the values that we are having. Okay, so you can just do that with any other value. So for me, that is what I am having. So that is the end of today's tutorial. If you get anything out of this tutorial, make sure that you hit that like button and make sure that you share this tutorial with your friend. Of course, just to help me to reach more people on the YouTube and even outside the YouTube. With that being said, thank you, and I will see you in the next tutorial. Thank you.